Well, hello and welcome back to my workbench. It is time once again to fix something. And today on my workbench, I have a PS5 Slim Disc Edition that I think is totally dead. Let me read you the description. Non-working PS5 console disc version. This wasn't damaged or dropped. It just stopped working. So let's see if that's true or not. I'm going to try to give it some power. And I did not notice the supply voltage dip. So it looked like the power supply did not start. So, all right, let's get the covers off and see. It looks like it did power supply. Let's see if that's what it is. And with the side plates off and the Blu-ray drive out of the way, we can see that it is still factory sealed. Gotta love that. So let me get this thing on down to the power supply. I'll get it apart, and we'll swap the power supply out with a known good one, and let's just see if that repairs it, and then we'll go from there. All right, I have slipped a known good working power supply into this chassis. Let's see if it'll turn on now. I think I've got enough hooked up. Let's see. Oh yeah, we're turning on. Looks like it's detected. All right. Yep, and we are starting up. Excellent.
Press the PS button on your controller.
Like it's been reset. Well, maybe not.
New notification.
Let's see if we can get this power supply going. How's that sound? All right then. So we have proved that we just have a bad power supply. So let's see if we can crack this thing open and fix it. I do hate opening these supplies. They are a pain. These Slims are worse than any of the rest of them. But we gotta get it open. See, wasn't that easy? All right, I'm pretty sure this supply is totally dead, but let's make doubly sure. We will discharge these capacitors. Nope, there is voltage there. So I'm going to say the main fuse is still good. Okay, we're discharged. Yeah, most likely that fuse is good if it's charging up that capacitor. Alrighty. See if I can fix my camera a little here. Alright, we're in continuity mode. Is our fuse still good? I'm untangling my leads here. Fuse? Good, 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 good. How about this fusible resistor? Good, 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 good. Any short on the output? No. Capacitor's charging up. So, no burn marks back here. Do we just have a bad DAP056? Possibly. Because if we had a shorted MOSFET, something would have blown. Either the fuse would have blown or that fusible resistor right there. One of those would be open. Because something has to give. Alright, I see pin 1. Let me find the negative end of one of these large filter caps. Right about there. Positive lead on that, and then we'll go in diode mode. 1, 2 is shorted. That was quick. Pin 2 is shorted. Pin 3 is very low. 0.2. 4 is ground. 5, 6 is low also. I think that's pretty low. 7, 8, 9, 10. 10's a little low. 11, 12 is not connected. 13 is shorted. Very shorted. That's 13 is the supply into this DAP056, and it is shorted. 14 is also shorted. Not sure what that is, but it's shorted. 15, also very low. 16, also shorted. So, possible lightning damage. Did it just get the chip? I mean, to blow it that much, some kind of a surge came through the AC line, and it may have gotten something else. So let's get that chip changed out, and then we'll see how many shorts remain afterwards. Alright, so we have replaced our DAP056 with a TEA2017. And I want to see how many, if any, of our shorts remain around this chip. Negative terminal of the filter caps. Pin 1 no longer shorted. Good. 2, 3. 3 still seems low. 3. I have to check on that. That seems low. 4, 5, 6, 6 seems low too. 7. No, 7 is no connect. 8 is good. 9. 10. 10 seems low. 11. 12 is no connect. 13 is now not shorted anymore. 14. 15. 16. I'm sorry, my meter's not in the picture. But pin 2 is good. 3 is questionable. 0.2 of a volt on pin 3. Let's take a look at pin 3 and see what it does. Pin 3. Nope, I'm wrong. 0.206 is normal. Totally normal. So maybe we don't have a problem there. That's different. Okay. Then maybe we're ready to test this then. Maybe. Let me get set up so we can so I can show you everything. Well, I decided not to go ahead and apply power to this because I was kind of remembering that we still had a low reading on one of these pins. We need to chase that down before we put power on this thing. I believe it was pin 6. Let me find my ground. Got it. Pin 6 in diode mode. 0.353. And that should be like 0.6. 0.66. So we have a low reading. Now that is that's the gate drive to, I believe, the high side MOSFET. Let me look here. You can see it right here coming out. There's a Zener. Let me look over here. There's a Zener to ground. And you can see it goes on across. There's a 15 ohm resistor. Which one is this one? Nope, it's going to be the low side MOSFET. Yeah, 6. Go over through R18. Through this resistor and diode combination into the gate. So it's Q4, the low side MOSFET for the 12 volt generation, is where we get a low reading. Let me go back over here. If I go to resistance mode and put my black probe on ground, let's just go to pin 6. 346 ohms, 347. And that you can see traveling right underneath here to right up here. And there's that Zener, ZD39. And if we check right there, of course, we still get that same 347 ohm reading. And here's that 15 ohm resistor, R18. So right there is our 347 ohms to ground. And if we go to the other side of that resistor, 332. So it's lower on this side, the side toward the MOSFET. So yeah, 347, 332. So it kind of leads you to believe our low resistance, our problem is beyond that resistor. This direction, which travels around, goes to right here. Goes through this diode and resistor here, which are in parallel, into that gate. So let's lift that gate of that Q4 MOSFET. And I'm just curious if that low reading goes away. Because if it was the Zener, you know, the lower resistance would be on the other side, closer to the IC. Let's just see here if we can lift this successfully. just want to lift this gate pin. Hopefully I can do it without breaking the leg off. That happens sometimes. Alrighty, are we clear? I don't think we are. Alright, I think we're clear now. So now what do we have for resistance reading? Well, we'll just go all the way back to pin 6. Where was it? Right here. Get in focus. Negative probe on the negative side of that large filter cap. And pin 6. 10K ohms. That looks much better. So it does look like our MOSFET has been damaged. So let's get that changed. I do have some of these. I did go ahead and buy some when I saw this slim power supply was coming out. Let's see if we can get it changed out. The particular MOSFET that is on this board, this particular power supply, is this AP60SA380DH, and you can see the specs for it there. Now, this is on there sometimes, and sometimes it's another part, which is the one that I have on hand. So if you notice the specs for this one, 600 volt, 0.38 ohms resistance on, 10 amps of drain current. Now, the one that I have on hand that I'm going to be replacing it with is this part, STD13N60M2. 650 volts, 380 milliohms on, 11 amps drain current. So this is installed from the factory on some of the ones. The ones that I originally looked at had this particular part on there. So this is, and I think I'm going to replace both of them since they're different manufacturers. Probably be fine, but I think I'm going to go ahead and replace both of them instead of just the one that's failed. All right, here is the MOSFETs that I removed. And I believe this is the bad one. Let's measure between the, let's see, the gate and the source in resistance mode. Yep, 183 ohms. And let's check this other one out. This other one should be good. We'll check it the same way. Yep, pretty much infinite. So, yeah, that one had broken down. All right, I think we're ready to test this one this time, I hope. I don't see any other low resistances. All right, then, I think we're ready to test this supply. I have this blue meter here across the boost capacitors, looking for 395 thereabouts. And I've got this meter across the output terminals, and I have a DC load connected, set for 5 amps. And it's on. So I'm going to give it, I'm going to turn this voltage all the way down. We're going to bring it up slow. And let's see what happens. I think we're ready. Okay, I'm going to check the current. Yeah, no current draw yet, so No shorted bridge or anything like that. Bring it on up. Is she going to start? Nope. Nope. She tries, but she's putting in about 1 volt and shutting down. Well, I didn't notice where this boost voltage was running. Let me see. That doesn't look too far off. So it looks like our PFC circuit is working. Our 12 volt circuit is not working. Okay. Okay, so we got to find another problem. Okay, so we still have a problem causing this power supply to shut down. And I want to take a look at some of these opto-isolators that are involved with controlling this thing. Get my red probe on this negative terminal of this boost capacitor over here, and I have discharged it. It's completely safe at the moment. I've discharged the boost voltage. So we are safe. Let's look. Yeah, we'll start up here. This is IC53, and we're on the hot side. The left side is the hot side of this over here. Cold side's on the right. So I'm concentrating on the hot side. This is going to be pin 3. Ground, that looks normal. Pin 4. 0.695, that looks normal. What about here? This is IC52. Pin 3. OL. Pin 4. 0.7, that looks normal. It's going down to the last one here, IC51. Pin 1. OL. Pin 2. 0.02. That is not normal. And that is driven by, you can see it right here, Q33. And we can just slide over to the side a little. Q33 is right down here. So I'm going to guess this has shorted, which is likely because it's connected back to the AC input. It's sensing the AC input voltage. So if there's a spike coming in, it's likely to get popped. So let's replace it. Go ahead. I was going to lift it and check, but I think I'm just going to go ahead and replace it. Yeah, let's go ahead and do that. All right, we are set up one more time to test this power supply. That little tiny MOSFET has been changed. We're metering the output voltage, we're metering the boost voltage. We're going to turn this down all the way, bring it up slowly. Load is on. What's going to happen? No, same thing. Exact same thing. More damage. Great. Okay. Boost voltage is still looking nice, but our output voltage is shutting down. Okay, that's the way it is. Well, I really thought that MOSFET was going to fix it, but it does look like we have other problems. And we're taking a look on the other side, on the cold side of this power supply. And I'm going to short out the output terminals to make sure there's no residual DC voltage out there on the 12 volts. You know, that might skew my readings. So we're in diode mode. We're looking at the DNP014. I'm going to put my red probe on the common ground terminal on the cold side. And we're going to start on pin 1 of this chip. That looks good. Pin 2. Pin 2 looks odd to me. 1.27 is not right. Okay. It's too high. Pin 3.08, that's too low. I don't think that's right at all on pin 3. So that's a problem. Pin 4.06, that seems really, really too low. And I have shorted the output terminal, so there should not be voltage there. 0.133, that's also low. That looks normal. Normal. What about on pin, what is that, pin 8? That's ground. I think that's normal. Pin 9. 0.04 on pin 9 is not normal. 10. 11. Maybe it's kind of normal on 11, looks like. 12. 12 seems really low. 0.08. Yeah, that's not right. That's not connected, but still, it's not normal. 13.09. That's not right. Pin 14.33. All right. So that's a whole lot of low readings. I'm pretty sure our DNP014 has gotten popped by whatever surge hit this supply. So let's get that swapped out, and then let's see what happens. Okay, with the DNP014 swapped out, I think we're ready to test again. Is the third time the charm? We shall see. Again, we're monitoring our boost voltage, which has been working fine. I think 395, it looked pretty good. If we can get it to not do that erratic 1 volt shutdown thing. Load is on. I'm going to dial this down. On. Let's see what happens. There we go. Much better. 12 volts, 5 amps. 395, 396 for our boost voltage. That's perfect. She's working. So yeah, quite a bit of damage on this one. All right, I will put it through its paces. I'll give it a full 31 amp load, make sure it can handle that. And if so, then I'll slip it back together and we'll put it in the chassis and check it all out together. How's that sound? Well, this PS5 is fully reassembled with our repaired power supply. I did check that supply up to 31 amps. It worked fine, no problem. I did also check the liquid metal and cleaned it up on the board while I had it apart. It was fine, but I like to go ahead and check it. So now let's see if it will actually turn on and power this PS5 Slim. Blue lights. Gonna get some video maybe. There we go. Much better. White light. And we are fully booted. All right then. So that power supply needed a good bit of work, but we got there in the end. That was really the only problem with this console. So anyway, I hope you liked that one. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I'll see you in that very next repair. Bye for now.